Hello! A little bit of a technical snafu there as I was trying to move things around, but we're all good, I think. Okay. Right, I've got the wrong camera on. I've not got a camera working. Oh, it's definitely a morning, well, afternoon, I guess, when things are just going to go a bit fuzzy. Let's have a see. Come on, there you go. Right, how are we looking? We've got a camera there, but it's not alive. Okay, camera. Hello. Can we see? Oh dear. Camera's gone walkies. Shall be one moment. Hello again. Hopefully we're back and live. And dun dun dun, drum roll. Camera! Way! Oh, it's really dull in here. Let's see if I get some light. Yeah, it's good enough. Right. Hello people. Right, so let us have a look at where we are, shall we? What were we doing? What are we doing? So last week we were, I can go to the System Variables repo. So this is the System Variables repository that has the implementation that we were doing last week. This is a implementation of system variables, basically a bunch of strings that map values, which can be read out by applications. Those are currently just a bare string lookup and value return. And we've got some system calls that allow us to read those values and write them. So those are not hooked into the operating system, but that's trivial to do, and we'll do that later. This allows us to basically test things out without having to worry about anything else. So, yeah, that's where we are at the moment. Excuse me. The intent here is that we'll have basically a replacement for the standard RISCOS system variable calls. At the moment, we only have the simple string lookup, so string to value. System variables have a number of other forms. If we go to the documentation of PRMs, I think in setVarVal it tells us, where's setVarVal? Down here somewhere. Here we go. So they can have different types of values. They can be strings, numbers, macros, expanded, which means use evaluate expression, literal strings, or they can be code. So all of these things are needing to be implemented. Currently we only implement type 0, which is string which can be GS trans immediately. And that should be GS trans on being set, which we are not currently doing. So actually what we've currently got is much closer to this one, type 4. So first thing we're going to try and do is try and change it over from being this literal type to being a string which is GS trans immediately. And I'm going to demonstrate the distinction between this. So if we go to RISCOS regular, RISCOS Pyromaniac, but yeah, just the regular version without the module in. And we'll start that up. So as you can see, there's a whole load of environment variables there. Let's set our own. So set one called foo, and we can set it to hello, and then we can show it. Show foo, hello. We can also do show foo like that. Fair enough. But we can also do things like this. So we can do hello 65, and if we show that value, we see that it comes out in either form as being hello and then the capital A. This string has been transformed and made into a capital letter A. It's been passed through GS trans. So the whole string gets passed through GS trans by default, and we're not currently doing that. So we need to do that. In order to do that, we need to call GS trans, which is pretty easy to do. And I may have an example of having done so before. May have done, not sure. We'll have a see. So if I would have had one, it would be in, probably be in one of the modules, sources, not message trans. Message trans doesn't do it. oscmans does though. No, kernel extracted and oscmans too. So have a look at the new implementation of oscmans and have a quick see in here. We should have. We've got a gstrans call in here. We have. So this is a bare gstrans call, and it just expands things out. It'll also return errors if things fail, so we can handle that. Okay. So, easiest thing for us to do is to take there's a copy of this function and put it into this module. So we haven't currently got an os library, so let's create one, an os module out of it. So let's copy the lot. So os interfaces, let's give it a new date because we're just starting it again. 28th of September, not October yet, thankfully. Right, there we go. We don't need any of these. Don't need any of them. Read escape state, no. gstrans, that's what we want. And oh, we're going to need evaluate expression, I think, because if we have a look over here, we get a os evaluate expression, so we will need that one as well. So I will copy that. Os word, os exit, yeah, with all those can go. So just those two functions, and then we'll create another os library here. It's arguable I should be using oslib here, as I created oslib for this very purpose, but I haven't, so it could be replaced at some point. It's really not a big deal. I'm kind of regretting not having done that, but these are all relatively simple, and I'm trying to do this as quickly as possible so that we can just get something that's working. The sooner we get something that's working, the sooner we can actually have other people doing things with the system. That's the idea anyway. Right, so that's the prototypes copied over. Let's just update the date on that as well, 20th of September 2025, blah, 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 blah. Right. So if we have a look in module, yeah, we don't need that anymore, so let's make this a bit bigger. Set var val is where we're looking. Sysvar create data len type. Okay. So this is what we're doing. We're doing conversions of the data type. So if a switch would probably be best, wouldn't it? We'll do a switch for these. Switch for each of the types we want to use for extracting the data. So if case, I think it's SVT. Actually, I don't know what it is. I need to have a look. So let's have a look in header variables. SVT string, and I've used the same names pretty much. So it's expanded and string are the two that we care about. Not expanded, literal and string, sorry. So string should be passed through gstrans. Actually, let's copy the lot and we'll do them. Natural isn't a thing, natural's for the outputs. All of these, case, colon, there, break, and I've got a new line between them. Here we can use default, is there a bad type error? Bad type. So sysvar create also returns bad type. So the type here that's being passed into here is the type we're going to store. The type that's being handled here is the conversion type, so to convert it to another form. So very slight distinction in that, but because when you read them back, strings are still strings regardless of how they came into the system. So to be passed through GSTrans is a 4-byte value. So when we're in 64-bit, let's actually note this. So in 64-bit OS, this will remain as 4 bytes, and a new way of setting the value is required. SVT number 64. Let's have a think about that one. We can have a see. It's not like it's something to worry about at the moment, but just make a note that we've done that. Macro same as literal on store GSTrans on read, and expanded is should be passed through evaluate expression, and then literal straight through. Okay, so GSTrans here. Both GSTrans and string want to go through the GSTrans routine, so letters, I suppose we should have a function that does that, because we're going to need it for these two, and we're going to need it on the read as well. So let's give that a yeah, the read will be actually slightly different. That's okay. Yeah, we'll look at that. All right. So let's just do this one first. So do the string here. Actually, what I'll do is I will merge string and macro. SVT string here. Both of these cases go together because they're both the same. Then we don't have to like call them separately. Excuse me. Right. So what we need to do here is to GSTrans the string, which is fair enough. I've forgotten how GSTrans works. Yeah, here we go. Let's just copy that. Right. So we want a kernel loss error, which I think we've actually already got one of those. Oh, we haven't. I haven't got a kernel loss error. Yeah, fair enough. Equals os GSTrans. Not sure what the flags should be. The string we're trying to translate is CS string. CS string already handles, GSTrans already handles CS strings. And so the next thing is the output buffer. Output buffer. I need an output buffer then, don't I? So char star buff. We're going to have an initial buffer size. Extension. Get the way around. Buffer initial and buffer extension. So I've written this just recently. Almost certainly I have for other particular uses. because many of these routines are exactly the same implementation. This is going to be very inefficient at 16 bytes, but that's good enough for now. Output buffer is going to be buff, and the size is. Oh, we need to remember the size, don't we? Buff size, buff len. There we go, buff len. This initial buffer, and then this can become buff len. Question from AI guy that says, "Do I know system design mainly LLD?" Don't know what that means. I know system design in general, but don't know what mainly LLD is. I spent a lot of time doing operating system design in the past, and we did actually do a little bit at university, but it wasn't very useful. But yeah, I do system design a lot of the time. My day job is DevOps, so low-level design. Low level as in hardware. I don't do a lot of hardware at all. I do implementation of, I have done in the past, implementation of hardware setup for device drivers and the like. But I don't do that stuff these days, thankfully. Hardware I stay far away from most of the time, which is why a lot of my work is in Python. Just saves me from getting stuck into areas that are less interesting. I like the higher level operating system design, but yeah, that obviously trickles down to low level design and how different parts of the system work. I spent a lot of time talking about that in my Riscos Rambles. If you're interested, if you look at gerph.org/ I think it's Rambles, you'll see a lot of, I think it's Rambles, not really sure. Yeah, that's right. There's a lot of discussion about my original work and then how I designed the operating system and how I did number the different parts of the system. A lot of stuff in there. Right, bufflen here, and readp. Readp is the how much we read, isn't it? End pointer. I think that's right, how much we read. Let me just have a check back on the implementation. Where to store the number of bytes read. Ah, right, okay, that's actually the output. So this is, oh, number of bytes read. Do I care about that? Probably I do, yes. Do we actually? Oh, I'll just read it anyway, and we can decide later whether we need it. Okay. Right, that's the call, isn't it? I don't need that anymore. So all we're doing here is going around the loop and repeating this over and over again. So while true. Oop, no, press down rather than. Oh dear, what did I just do? I jumped the wrong way in the code. If we had an error, it's probably going to be a buffer overflow. Error number underscore buffer overflow. So what we do here is we do new buff, oops, in the comment, new buff equals realloc buff with a new size. New bufflen plus buffer extension. Bum, bum, bum. And after we've done that, if new buff failed, run out of memory. Right, in which case we need to return an error. Is it no memory? I think we've got a no memory error down here, haven't we? Yeah, no memory error we've got available. No memory. There. And then if it's worked, we do buff equals new buff, buff len, of new buff len, and then we let ourselves go around the loop again. And actually, so if there was an error, if the error was buffer overflow, we're all good. Otherwise, if it wasn't buffer overflow, we just need to return the error because we can't handle it. However, I need to free that buffer as well. Free buff. Actually, what? Oh, come on, what have I just pressed? I pressed page up. No, there we go. Okay, to get rid of that and save it, what I should get is an alert from the. Oh no, I haven't balanced my brackets. There we go. If I save it now, I should get an error from the checker linter to say I've leaked some memory. Oh, actually, I leaked memory up here as well, didn't I? Yeah, it hasn't spotted it. Oh, it hasn't spotted it because I've done this. Let me just do 0 there. I need to work out what that's going to be. Failed parsing. So I think, come on, we should get an error out of these 2 lines. No, it's giving me an error up here saying that's an uninitialized variable. Oops, because I forgot to initialize it. Sysvar type T R4. Oh well, it didn't spot that, but there was a memory leak, and we should just go and free it. Free buff, and again free buff here. This is inefficient. We'll deal with efficiencies later. There's a lot of ways I can do this differently. And if I was thinking about it a bit more carefully, I will be doing that, but I want to get it working and then I'll make it more efficient. So if this is no error, we've got our string. So if we got our string, we break out of this loop. And that takes us to here, at which, oh no, sorry, to here outside the loop. And we now know that the, oh yeah, this is a good, I'm going to have to make it more efficient now because otherwise I'm going to lose me, I'm going to leak some memory anyway. I'll show you in a second. So the data that we've received is now in our buffer, and the data that we want to use is now the buffer len. Oh no, it's not the buffer len. It's the length that we read, bytes read. There. And just in case anything goes wrong, we'll set that to 0 so that we don't have random things happening. So the reason that I was suddenly thinking, oh, I've got to make it more efficient now is because I was hoping I could allocate this just for the life of this call, but I can't because after I leave the scope here, this will be leaked essentially. It won't know that it was something that should be freed. So what I'm going to do is I'm going to move this up, not like that. I'm going to change how it's called. So we're going to have both of these are going to be called GSTrans buffer. Oh no, I've done that wrong. Duh. GSTrans buffer and GSTrans bufflen. There's certainly a problem here with reentrancy, but we'll worry about that later. And then here, bufflen equals 0. Buffer equals 0. So we start out with null. So if gstrans buffer is null, so this is if it's the first call, then buffer equals bufflen. Ooh, fingers not playing ball today. No memory. If we failed on our first one, then we are stuffed. Gstrans underscore bufflen equals initial. In fact, I should have gone to a variable here, shouldn't it? Yeah. And you'll notice that I'm using the buffer as the actual distinguisher here for whether it's freed or not. Bufflen, because if I used bufflen as being the distinguisher of whether it was allocated or not, then if something failed here, we would end up with the bufflen being set to buffer initial, and that would be a problem. Because then the next time we came through, it would pass straight through that check. Bytes red equals 0, put that there. Buffer initial, let's put this up here. This can all be made more clever for reentrancy later. Not a big deal. Now we don't need to free it because we know it can be just fine. And if it's any other error, we don't need to free it there, we just return the error. Error in gstrans. Okay, so that might be something like you've missed a bracket off, or some of the system calls reduced errors or something like that. We know we've got our string, goes to their buff. This is gstrans buff. And bytes red is bytes red. Cool. So this should handle both string and macro in this instance, which is okay. The only thing we've missed here is the value of the gstrans call here, which is 0, and that's something I need to check. If I just check in here, did I have the gstrans values? I didn't. Oh, that's silly. Well, let's go and put them into the OS header. So here it says what their values are. So we're going to want to put those into here. So here we go. Hash define gstrans no quotes is 1 shifted left 31. gstrans no escapes 1 u shifted left 30, and gstrans space terminate 1 u shifted left 29. Okay, and for our use, oops, not that source, this source here, not read var, this one here. For our use, I think we just want the value 0 because we don't want it space terminated, we do want escapes, and we do want quotes. Ooh, actually do we want quotes? I'm not sure. I don't think we want quotes. I think no quotes is probably the one we want. gstrans underscore no quotes. Right. So this is where, when there's a question, we can go and look up the answer. So to look up the answer, let's go and have a look at Viscous Pyromaniac, which I don't have available here. Let's just pull up a new terminal. And if we cd into /pyromaniac, we can just pull up the source here. It will be quick and easy to do. Whoops. Right. I want the file, well, the one that implements the SWI set, SWI for variables, it'll be. So SWI var osvarval, here we go. Yeah, I don't think it does it the same way, so yeah, it calls into the SystemVars module because it handles it in a separate place. SystemVars pi. If we look down here, oh yeah, we do all sorts of, we actually have, in the Python version, we have a different class to handle each variable type, which actually makes it a lot more flexible for us. It's really useful in the Pyromaniac side because it means we can do a lot more clever things. However, right now, that's not what we're worried about. We're looking at the GS transcode, which will be here somewhere. Let's find GS trans. Use escapes is true, quotes are special is true, and terminate on escape is false. So I think that's, yeah, I think that means we're using 0. So you can see here we actually call a function inside it, we don't call the system call. And that's probably not quite right, but yeah, that's not too bad. Not sure that's completely correct there. It's not always like that. Yeah, that looks like it's wrong. Yeah, well, it doesn't matter. I'll come back to that later because that's not an issue with the module we're writing right now. Oops. Right. Has been, oh, it's probably just saying it could unused variable oh no, because it's been shadowed by this one here. System variable error. We'll just change the name of that so we get a correct SV error. SV error. There we go. All right. No conversion of the data type. Yes, there is. No code variables. Well, that can just go into here. Yeah. No evaluated. Excuse me. Right. So I think this value is 0. There. Okay, that looks possibly reasonable to me. However, what we can do is we can actually check it now and see what happens and see whether it even builds. So I'm going to build the Riscos. It just linked it. It didn't do anything else. That's a little odd. What? Shouldn't you have like actually built some code there? Oh, because it's building the variables test. Right. I'm going to swap these around. I'm going to make this one make test and make, and the regular make file is for the module, because the module is the primary thing we want to be doing, and that'll make it work better. It probably also means I need to change the Riscos build thing here. Yeah, so build the test will now be make test, and make file will be make that one there. There we go. So that'll now work. Okay, back to where we'll close that. That's not needed anymore. Excuse me. I also want to add the OS into here because we added a new file. There we go. Go back to module and build. Implicit cast of pointers, a non-equal pointer, and that's because one of those is a char star and one of them is a uint8. So let's make this one a uint8t star. Ease. Implicit, ooh, loads up here. Let's start from the beginning. Right, implicit cast, right, inventing that, sorry. Let's go to the top and include it. Include os.h and then rebuild. First error, type declared but not used. Again, we haven't assigned it. That's quite interesting. A little bit of a mistake on my part. R4. How to extract. Build again. It'll still say it's not used, but that's fine. Right. Inventing buff. Because it's no longer called buff, it's called GS-trans. Buff. GS-trans? Trans. And this one is GS-trans bufflen. Did I call it bufflen or did I call it bufferlen? I called it bufflen, that's okay. Implicit cast of not, that's because they're not known. Error number buffer overflow, right. So we need to include the errors header to know what that is. So let's do that. Hash include. Letter's gone wrong again. Very wrong. Riscos/errors. Is it errors or new errors? I think it's new errors. Not actually sure. I will find out. Didn't give me an error there. Still didn't find it though. Bother. Okay. Let's just go back to the terminal here. Viscos kitten c:h dot no c:: viscos dot h dot new errors. There we go. Overflow. Error number buff overflow. That's fine. There we go. And then I can go back to here and rebuild it. Oops, no, don't. I told it back again. No, stay big, stay big. Thank you. Right. Unknown value bufflen. Yeah, that's right, because this should be GS-trans bufflen, and this should be GS-trans buffer. When I renamed them, I didn't rename them consistently, and then this also needs to reassign it properly. This is where using a different sort of editor would help, where it had a bit more intelligence to be able to change those variables, but yeah, I'm a little bit too old school for that. And yet I'm still far away from most of Riscos developers, because most Riscos developers develop on Riscos, it seems, which means that they don't have a bunch of this functionality. Right, but this has now given us a, what is that said it's not used? Oh, it just says scope can be reduced, that's fine. All right, we've got a module. It's built successfully. So let us actually try and use it. Bounce this to the top. Riscos ammo and pyro. That's me testing. What am I testing there? Oh, it's resource fest I'm testing with that one. rm32 / oh, I'm in the wrong sources. SystemVars, there we go. So if I now find a command line that's got that in, and we drop the command line, I'll go to basic, it'll be easier. that's going to fail because it's going to say I can't find the command basic. Command basic. There's no switch called basic. Oh, and that's no longer called makefile module. Yeah. Okay. Woo! Nearly ended up with T over everything. Wouldn't be the first keyboard I've soaked with T. Right. Now, somewhere in the history here, we should have... somewhere in the history, there's a lot of testing of resource-fs. A lot of testing of resource-fs. Well, it's been a week, I suppose. It's not surprising. Oh, here we are. Here we go. Right. So this was the system call where we just read var val and a set var val. So there's set var val. I'll find the read var val as well, just to prove that those that have not become broken. Oof, long way down history. There we are. Come on. There we are, read. I printed out the wrong thing there, didn't I? What? Because that's actually not working, is it? I said I wanted to read the variable sysname and put it at 9000, and it's read the value sysname. It should have given me the value hello. That wasn't working before. Interesting. Interesting. So either I've copied the wrong buffer or I've set the wrong value. Either way, that's not right. So let's go into the variables. Do I have some debug? I have some debug in here, which apparently I'm not using because it doesn't actually print anything out. So SystemVars dump. Yeah, we have a dump command here. That's quite nice. Oh, didn't it have a command that was doing so? Star SystemVars. There we go. Value sysname. I've set it to the wrong thing. That probably means it was working and I've now GS trans the wrong thing. Let's have a look. Yes, I should be GS transing the data, not the... There we go. GS trans the data. At least it's easy to see. Oh. Implicit asset, oh yeah, fine. Okay, because that's a const char star there, please. There we go. List the system variables. Hang on, what? Oh. Hang on, what? I thought I said I had a command here that would debug that. Oh, I'm confused now. Why did that work before and not now? Because I ran star system. Oh, then it prints out dying. Then it did variable system. Oh, is that because when I kill it, it goes and does that? Okay. Just a second. Dave says that YouTube's not letting him chat, but it might be his browser being weird. Let's do some hellos. Hello, peoplings. Our guy is watching and learning, so apparently this is working. Sorry, Dave, I don't know why it would be. I have found problems with Firefox in the past that it doesn't always work with the chat, but that, I don't know. Everything's, yeah. I mean, maybe the YouTube isn't the right place for this sort of thing. Maybe it should go somewhere else, like Twitch or something. Although that does make me twitch. No, don't really want to do that. That's gamers and stuff. Right. So what I'm actually going to do here to make this a little bit more flexible for me is I'm going to create a command for doing this testing. So I swear I did this last time, didn't I? Or maybe I only did it in ResourceFS. So if we just have it, I'll just show you ResourceFS here because this has got exactly the right bit of code in it that I want to be able to pinch, or example anyway. This is ResourceFS's module header, and as you can see here, we've got a set of extra commands so I can do debugging on it. And that's exactly what we want here. So what I'm going to do, I'm going to copy and paste it and then stick it in. Because here we go, we've got SystemVars list. And then that can do the dump command. List all system variables for debugging. And again, handler is command SystemVars list. And we don't need any others at the moment, so we'll just get rid of all the other commands, but just one command so we can actually get some debug out of it. Does that look okay? Yeah, that looks fine to me. And that was debug command, so we jump back to ResourceFS here and have a look in the make file. You'll see in the make file here I've got an extra options field that sets debug commands. So we'll do that one here as well. Options modules wise, options plus equals debug commands. Okay. And then, so I didn't mean to drag that one, like this one here. And just drop the ResourceFS out of the way, don't need that at the moment. And then in the module, we're going to add a new function for that command. And the easiest way to get the function that we need to implement is to get it to fail. There we go, that's the file that's there, but mod command. Do I need to implement a dummy one? I think I need to implement a dummy one. So let me just steal a dummy function. How did I do the dummy function here? Nothing, it's all handled by the... Could have just pinched that anyway, doesn't matter. Paste. And then inside the header file here, we'll have the command as well. I think there's a way to actually make it not even generate the call to mod command, but I can't remember. I'd need to have a look at how cmunch works. Right, and these are only implemented if we have debug commands set. So if def debug commands vars in here, sysvars dump. And then return null because we don't want to know that. And actually that function also only wants to be there if we're debugging. So let's just put that around there as well. Okay. Let's move the resources file out of the way again so I'm not distracted by that. And then build it again. Right. Now, run our test again. Hi Dave, it seems to be working on the chat. Don't know what was going on there. Sorry. Set varval and then read varval. We're now getting a hello. Good. And if I do star SystemVars list, I can see the variables. Excellent. So the other bit, the bit we're actually wanting to test here is if we do this with 65 there, do we get? Yeah, we get it. Oh, that's wrong, isn't it? Oh, yes, I've not implemented update. I've only implemented set. Okay, so that's another thing I need to do. But it is working. It's just not doing what we want. So, with that in mind, are we now happy? So we've done GSTrans input. I also want to check whether if I set it as a literal value, so if I set it as that literal value here is it's in this register, isn't it? Literal there. So we've now set it to hello 65 like that. And do a show. Where's my show there? Right, that came out there because I gave it a length of 65. A length of 5 rather, sorry. So actually I want it to be 6, 7, 8, 9. 5, 6, 7, 8, 10. I can't count. Oh, no, I wrote 9. Rotation. Is that right? Plus 4, yeah, that's right. Yeah, so there we go. That hasn't GSTransed it, so that's what we want. I think that's okay. It might be wrong, but I think that's right as it stands. However, we've also got the type coming out as type 4. And I think the type should actually be reset to be string again. Is that right? I'm not sure. We can find out. Yeah, we can find out, can't we? Because we can do os set varval here. And then instead of the SystemVars one, we can do the os, the os read varval. Sorry, where's the read varval gone? There we go. Os read varval there. So if you set it as type 4, it still comes out as type 0. So yes, that needs to be tweaked as well. So I go back into the module, and the SWI handler here wants to change so that in both these cases it's SVT string. Type equals SVT string. Build that. So set varval with type 4, and then read varval gone. There's read varval. Comes out as 0. So that's now no. Those are the os calls. I want the SystemVars call. SystemVars call, and the SystemVars read to go with it. Yeah, that one. What do you mean it's coming back as 4 again? Did I not? Oh, because I changed the wrong one. I should have put that into literal. There we go. 9 and 8 mix up. Interesting, you're right. Length has come out as 8. Oh, that's big, yes, because I set it as 8. Let me set it as 9. Read it. Now comes out as 9. And yeah, the bracket was missing. Right. So this is a little bit frustrating because I'm making silly mistakes here. So stop making stupid mistakes. Write some test code. I'm going to write it in BASIC because I can. So here we go. Let us start with a simple file called test set read. I think this is going to be pretty poor, I'll admit. And we're just going to call these twice. Oops, didn't mean to move that as well. Come on. Oh. Please. Thank you. Test, set and read. Right. So we need a buffer we can actually use for this. So buffer, let's just have 256 bytes. It's good enough. So there we go. Let's test that setting. Print it out, it'd be easier. Test that setting variable with gstrans works. Where's my read var val call? Here's my read var val call here. So this is the gstrans type 0. We want to get it out of our buffer, not out of a random chunk of memory. And print len context and then this bit reads out the string. We'll just do that. Let's modifications for that. For now, this will do. It's not going to be anything particularly special. If len is not equal, well, I've copied the version, the one with 8 again, haven't I? Dave caught me. See, it's good to have somebody who's actually checking me. If len is not 9, then print error. Actually, we should probably. Yeah, I'll just print out an error to a now. Error failed to failed. Length was wrong. There we go. Let's do that. Fail equals false. Fail equals true. If fail is sent, then error ext failed the test. This is very poorly written, but it doesn't really matter. It just needs to work, basically. That's the length, and we should also get back type as being not 9. Should be type 0. So if we just, oh, and I'm calling os as well. I'm sure Dave spotted that. No, he didn't, or at least didn't mention it. Right, let's see whether that works, shall we? So we can run that with /test set read. Okay, that wasn't quite working as expected. In fact, that was very much failing. And I think that's a bug in the basic that I'm using. I thought I had fixed it as well. So that, if you load a basic text file that doesn't end in a new line, it would crash. And I thought I had fixed that. Genuinely thought I'd fixed that. Oh well. I may not have copied it into the right directory here. That may be all it is. Anyway, length was wrong. Failed the test. Well, you're right. It did. The length was wrong because that was the literal. So. So this is actually the expectations for type 4, literal. Is literal. And this one, when it passes it in, it should get it back as 6. And should get it back there. All right, let's try that again. I think I'm going to do a separate these out. I could probably separate each of the tests out, couldn't I? I've done apostrophe between them. It'll separate them with a blank line. And then here I can do print text. I'll just tidy it up a little bit. And actually I can go and put this into the running on the CI system as well. Yeah, that looks like it's doing the right thing. So regular variables and those variables are working. Sorry for bouncing the cup on the table. I hope it didn't rattle the mic too much. So I think we're at a checkpoint. So let us checkpoint. Add C and H and test set read and makefile test. Okay, that looks good. What have we done? Let's swap the makefiles around. Added test debug code. What have we done in the C code, sorry? You're telling me we've changed nothing in the C code? Oh. Cached. Right. Yes, so we've implemented GSTrans and we've added some tests. So let's do this. Okay, so what are we doing here? This is the GSTrans of the type 0 variables is now performed in the set swy. I'll give it a proper name, set val swy. The buffer is global, so there will be the entrance issues. separately. The set and read are now tested by a small basic program which uses the module swise. There is a new, oh, I forgot to put the commands into the CI system. I'll do that in a second as well. There is a new star command which prints variables out. Okay. And let's just tweak the CI so that we actually run this. So if we, oh, not that one. It's this one here. Row build. So after running that test, we've made the module. Now we want to do, oops. We just do test set read. And if it gets to the end, it was successful. So let's commit that as well. Gerph. Commit that and add it to the commit we just did. I should probably have put this into a branch rather than putting it directly onto main. I don't think it'll really matter. Push. And then let's have a look at it. So if we go over here and into the actions, we should be able to see it running. Here it is. And you can see it's running, and oh, look at that! We got an error out of it. SystemVars dump. Referred to from. Oh! Because I bracketed that by if def, it's now failed in the test here. What we do here, we'll just do. I'll just make it. I'll just define debug command. Is it command or commands? Commands. There we go. Right, let's just make sure that builds. Riscos ammo make file test. Error, type of decode commands unknown. Ooh, that's an interesting one. That's not what I wanted in the plus debug commands. If you don't give it with a plus or a minus, it gets upset. Interesting. I can work on that. Okay. Let's actually run that test and make sure it works. Common command. That one there, please. Yep, they're all passing. So I can just tweak that into the settings and then push it with a force. This is why putting it on a branch would have been better, because I don't modify the main branch. Right, where's the action for that? So one thing that I did last week, if you saw us, was I updated it so that it used host ammo. Ooh. Why SystemVars set var val not known? I didn't actually load the module. Right. What I was saying was I changed it so that in this one, instead of using ammo, we actually use host ammo now. So that instead of us running that, so all I need to do is just comment this out, and then it would switch back to using it in Riscos. Whereas using host ammo means it builds it on the host system, and it works a heck of a lot faster because it isn't emulating the whole of the compiler and linker and the makefile utility as well. So the bit I'd done wrong was load the module, which is itself a test. Load the module, load rm32/SystemVars, and also it's useful to kill it at the end to check that it hasn't like failed. So let's do that. Oops. Because if there's any problems, we want to know about it. Kill the module. And kill SystemVars. I've got Tori Amos in my head now. Here we go. Come on, are you building? Yeah, there you're building. I'll just quickly search for that. Could have clicked on that and see it building then. There we go. Built. Why did that? Oh, that's because it's not called rm32/SystemVars. Too many blooming operating systems. Dot. Because we're in RISC-OS now. Again, commit and amend. And then push. See, it's sufficiently fast that I don't even see it starting the build process. There we go, it's just started. I just caught it then. Much better. There we go. And as you can see here, when it dies, it goes and still reports the variables. Probably also means that it's leaking memory, which is interesting. Right, so can I do something about that? If I remember rightly, we should be able to. I think we just do fortify equals yes. And then we just need to include some special calls into the module. So in here, we do I can include fortify.reach. Probably actually just brackets. Don't need to bracket it, do I? And I believe we do it here. We do fortify enter scope here, and then we do fortify leave scope at the very end. And we need to ensure that every single file includes fortify if it uses allocations. So variables here will need to do it. So we just do hash include fortify. Oops, no, it probably wants to go up here. Just moving it around because like system includes, library includes, and then our includes. Just try and keep them structured. So I'll get rid of fortify for this, and I think that's all I need. Let me just build that and see that it does build. Yeah, looks good. And then what we can do is right, so we'll do the normal thing here. And what we should see is that everything is fine, because we're not killing the module, we've never left the scope. But if I now do command rm kill SystemVars, there we go, we get some memory leaks detected, which is quite cute. The reason that these are coming out in different colours is because they're coming back through throwback, and throwback is giving us the colouring in the background, which is quite cute. But I know exactly where they're coming from, which is also handy. Whilst I remember, because I did say, I had Toriyamos going through my head. Toriyamos was going through my head because I was talking about killing the module, and there's a track called The Waitress, which opens with, so I want to kill this waitress. There you go and look at it if you like, but at least that explains where random comments come from. So all of these are going to be very similar. So the variables will be the fact that we've leaked the variable system. Do we have a SystemVars shutdown, SystemVars finalization, or something like that? No, we don't. So we want to actually have a function here that does SystemVars final. Finalize the system variables and release all memory. No variables. Nothing needed. SystemVars. SystemVars to start. No, I just said it's void. SystemVars. Yeah, it might be time for a break very shortly. Oh, I am sitting in complete darkness almost. Let me go and turn the light on. I've not looked at the camera for a while. Wow, that made next to no difference. Maybe I just need to close this window so that it can do better. Now it looks like I'm just sitting in the dark. It's not actually that dark in here. It really isn't. Okay, light, a bit of light there, and let us just very quickly. Oh, I can't tweak that. Yeah. Are you giving evidence? Yeah, it does feel like I'm being like questioned, doesn't it? Although I'm not, if I'm the one in the dark, then I'm with you. So what we do is switch the camera, and we just edit the filters on that. Add a video filter. Oh, I don't know. I thought it was a video filter. Give me a color correction. There we go. Ooh. How's that? Better? I think that's better. Yeah, so yeah, Dave says a lot of them work with a bright light on their face. I've got some lamps that I want to put behind the monitors, so it gives me a whole bunch of backlight onto this. But I put them up there and stuck them onto the monitor stand, and then they got so hot that they melted the glue on them, and so it all fell down. So that wasn't successful. Talia suggested some other things that we could do with that, and I haven't yet dealt with them. But yeah, that's definitely a thing. It's a pity there's no auto balance on this, because that would be really nice. Anyway, yes, these lots of fun things. For a reference from in the future, it's a 150 watt incandescent bulb here. Oh my gosh! So I've got a daylight bulb in the light above me, and that apparently was making no difference. But I think that's because it was coming from behind rather than in front. I'd still want to put one in, I suppose. Anyway, I said I should have a little a live or whatever button on air. That's the word. On air lamp to show that I'm actually broadcasting. maybe I should also have a you're too dim, your picture's too dim. I mean, I know I'm dim, but anyway, moving on. I'm trying to do something that goes and shuts down the system variable system so that we free up our space, because we're going to want to do this for releasing memory anyway. What we do is we want a malloc, and oh, CS strud up. That probably means there's an allocation in here. Oh, there's an allocation in here. I need to put include a fortify in there. Otherwise we're missing some of the leaks there. Okay, so literally all I want to do is go through the list, pretty much like this, and free all the entries. So equals SysVars equals null, and then that's nothing. There we go. And then we want to do free. Oh no, code equals. This is no longer actually in a for loop. It's just free cur sysvar next equals next. Again, all very inefficient. Doesn't matter. We will work it out later. Next. And we also want a free cur to both of them. There's two values, isn't there? There's the name and the value, which is called sysvar value data and sysvar value name. I deleted way too. Oh, data and name. Sort it. Name, please. So that finalization routine will free up a bunch of things, and we can put that into our finalize here. We don't need to do the dump. Don't need that bit. Don't need that bit. Just want that. We don't need to do a dump because we want it just to finalize. And then we also want to put into the variables here the finalization call. I accidentally pressed build then rather than paste. B and V are right next to one another. Build. Okay, F4. Undeclared name. Oh, because it's not called sysvar, it's called cur. It's called cur. Actually, as the days get darker now, it's pretty miserable out there. As the days get darker now, I'm probably going to need to set that lighting up, aren't I? I used to have. I've got a big uplighter beside me. It's the back of the room now. I used to sit it right beside me, and that did the job. There's a lot of things about doing videos live that are different to doing them recorded, because you can prepare it, you can see what it's going to look like, and with live you've got a bunch of changing circumstances. I mean, not that I didn't have respect for people that did live things, but it does make me appreciate it. Right, let's build. Right, so the only allocation we've got that's failing now is the allocation of the GS trans buffer. So what I'm going to do is actually create a new file that manages the GS trans buffer. Because if I do it that way, then if I want to implement it a different way, I can do that in the future. So this is GS trans management of performing GS trans on strings. date today is the 28th of September 2025. You know, the main reason for putting the date on there is not so much that I actually care too much about the date, although I do, because it's useful to know when things were written. But if you leave the header looking like that, it looks a bit pointless and small. So that's the other reason for having that there. Yeah, I'm sometimes a bit weird in my reasoning for things. Right. So let's copy this, put it here. Yeah, you know what? Yeah, I'm going to do this as a very simple thing here. I'm going to actually call GSTrans. So what we'll do is error. We'll get back an error. Not the flags, the thing we want to translate, and what else do we want to get out? We want to get out the buffer, which can actually go into output. It may as well go straight into there. The length of the buffer, which can go into data len. Oh, actually, it's not called output, is it? It's called data here. Called data len. And then the number of bytes read. So this is actually very similar to the call we've got here. In fact, identical to the call we've got here. But I'm going to wrap it also in the allocation code as well. Bytes read. And then if we have an error, we'll just return the error. All of this code should then be able to move into the other function. All of this code, that code. Right, so move this into here. And this is called GSTrans translate. And it has exactly the same 2-star flags. Const char star data, we've called the buffer here. Char star star GSTrans buffer and char no, int star GSTrans bufflen and char star star end pointer, const char star, I think, and we want to return a kernel loss error. Ooh, that's a lot of things. So let's separate out the inputs and the outputs. There we go. We need to have a loss error. There. Boom, boom, boom. Bring it back again. No, that was wrong. Output pointer. This is output len pointer. So output pointer star and output len pointer there. That's no longer a uint 8-star. It's just an int. No error. Oh, we also want to set the bytes read. Wants to be oh, do I want it to be the end point, or do I want it to be number of bytes read? Interesting. Might be easier if I just made it the bytes read, wouldn't it? Because that's the same thing. Bytes read pointer. L there are semicolon. I need to do some includes in this because I'm missing a whole load of things. So what we got include studlib the malloc, include, do we need string in here? No, we don't. We do need os.h because we've got that, and we need kernel.h. Oh, and std_int as well. Include std_int.h. Right, how's that look? Still giving me an error there. What's that complaining about? CP check warn. Oh no, it's now told me this is something different. That's just saying it could be scoped into here. So let's move that in there, and I think we're good. So let's document this function. Just translate. Ooh. Perform a translation through gstrans, allocating into a buffer. A bugger? No, a buffer. We don't use a bugger. Lines equals the gstrans flags. Output the where to store the newly allocated buffer. Put len_p where the length of the data will be stored. Bytes red_p where the length red will be stored. Now, I've just noticed that you got that wrong because that's a star. It should be just a star because we're actually only going to store it. We're not storing a pointer, storing a value, not a pointer. Yeah, we are definitely coming up to break time. Let's see if we can get this bit working, and then I think it will be time to go. Bytes red, that can just be bytes red now. Bytes red p. Probably working. Right. Need to add gstrans to the files will compile, which probably will cause things to break. But let's. Oh, and now I've got this error number thing, haven't I? So I need to copy that. It's no longer in here. New errors is no longer in this. It's now in here. Yeah, that looks okay to me, I think. Build it, see where we go wrong. Lots of things went wrong. That's a warning, don't care. That's because we haven't got a header for it, fair enough. Context not used. Okay, so let's create as a header for this. Copy this and put it into here. If the def just trans h. We need std_int and kernel, and that's it. I also said we return none. No, we return a pointer to an error. Or null if successful. Let's say, oops, not that one, this file here. Replace that with the text for that and build it again. Yeah, that's fine. We didn't include the header. That's the different uint8s and things. So yeah, this one's going to be cons. No, just jar star. int star. Maybe it should be a uint. If I cast that, that's going to potentially go wrong when things change in the future. Let's make it a uint32 star, and then we'll change the definition we replace. Bytes read is going to be an int. That one is going to be just a char star. And we'll just change this in here to take a uint32. And some of these can be fixed up in the future. But right now, I think just getting something that works is more handy. So header here, this one is just change that. Build that. Yeah, not worrying, not worrying. Inventing. Oh, all right, yeah, because we need to include mod head in here. So we get the error definition as well. Output len equals, no, that's not right. Output len is what is the output length? Because it's not just transbuff len, is it? That's bytes read, that's not the bytes that are written. Unless I've misunderstood. Where to store the number of bytes read? Have I documented this one? So read P is coming out in out2. Okay. Viscos PRM OS trans. I'm sorry. Can I just do that? Okay. Number of characters in the buffer. No, it's not the number of bytes read, it's the number of bytes output. Number of bytes written. So that's kind of interesting. Documented it wrong in the previous place. I'll probably maybe fix that there as well. Root P. So I need to fix up this in the header, which is here. That's fine. And this root P. Okay. Go back into here. And I don't need that anymore because it's actually output len P. Although the size of the variables will be different. What is it taking in here? It's taking an int star. So if I'm going to use an int star, I'll put it in here. So wrote equals wrote. There we go. Now I can change that. I probably missed something. Okay, let's just rebuild the lots because I'm a little bit unsure that I've actually done it right. Why didn't that leak? Because I didn't include Fortify in here. That's why. There we go, it's now recognised the leak, thank you. So the way to do this is then to have a GSTrans final to finalise it. Can't type. There we go. Free GSTrans buffer. There we go. And then I need to call that from module in its finalization code. Here we go. SystemVars finalize, GSTrans finalize. Extern GSTrans final. Ah, because I didn't put it into the prototypes in the header. There we go. Done. So with that in mind, we should now be able to build that, and we'll have it nice and clean. And when we do it here, we don't get a memory leak. Whee! Right. Status, and we'll have a break. Add C and H. I did fortify to check memory leaks. Okay, and push that, and if we jump back to here, we should be able to, oh no, not that one, this one, yeah, let's see how it goes. So we can't get there before it even, ooh, include fortify.h wouldn't open. Oh, don't tell me I didn't put fortify on the build service. Oh, that's very irritating. That's very, very irritating. Right, well, we'll just turn Fortify off if it's running in CI. That's less useful, isn't it? I'll fix that for next week. Or I'll find out what's wrong with it, because actually, that's a very good point. So start to start. Rebuild everything. Is it possible that it's actually not working for other reasons here? No, I think that's just broken. Oh no! No. This is because it's not actually doing Fortify in this build at all, which means that the test code here, yeah, Fortify equals yes, the test code. Actually, the test code probably doesn't want to. We don't need that there. So this is a different problem. Now make the test program. There we go. That's right. It wasn't that it's not on the server. It's that I set the options wrongly, which is dumb, and I could have tested that here. There we go. Built the tests, built the module, ran the test for the module, and killed it, and no errors came out. How's that for pretty awesome. I think that is indeed pretty awesome. Okay, status, everything is there at the moment. Yeah, let's call that a break now, and come back in about 10, maybe 15 minutes. We'll see how things go. All right. So just before we go, of course, what I try and do is do a little update on where we're up to. So what do we get to? We got system variables that use GSTrans are now handled. We've added in some finalization code so that we can free our memory. We've had some checking so that we really are freeing all our memory. And we've fixed up we've added in some tests for the SWIs to make sure that they're actually doing what we expect them to do. All of which gives us a bit of a better feel for how things should be going. We've still got problems with the fact that we're only creating variables, we're never actually updating them, but this is not a particularly difficult problem. We can look into that very shortly. We also need to handle enumeration as well. Those are things that are still to come. All right, let us take a break and be back in a little while. Okay. Hello, welcome back. Well, welcome back to me, I suppose. Right, so yes, we are looking at something or other. What we're doing, we've got system variables to the point where we have some checks on memory, we've got some GS trans handling, we've got some tests that show that we actually are doing the right thing. Bits we don't have are things like macro variables and what was the other one? The evaluate expression call. So if we jump back over here, we can see that the evaluate expression call is number 3 here. So let's see whether we can do that. It's possible that this evaluate expression call may actually be very similar in handling to the GS trans. So might want to put them in the same sort of bucket, same file handling, because I think they're pretty much the same style of we need to have memory and so on. So let's have a quick look. So in the module here, its evaluate expression is done on setting it. So we want the set var call. Expanded, so no evaluated values. Let's add an evaluated value. Ooh, fingers. Yes. Think. Yeah, okay. Sorry, just getting myself distracted. So this is basically the same interface as this output length, so and buffer pointers and things like that. So it's all very, very similar. In which case, it makes sense to put it into the GS trans file. So what I'm going to do is I am going to just call this GS trans / evaluate expression. Do it and call it that way, just because, well, why not? It would make the general implementation a lot easier if we just handle both of them together. Actually, if we rename these, we can call these transform, one called GS trans, and one called transform evaluate. And then we can rename the entire file. Expression. We don't have any flags. We do have some data, which is the expression. Expression. And those are all exactly the same. So this is going to be transform evaluate. Let's replace GS trans buffer with transform buffer. So we have names that are appropriate, and the same goes for GS trans bufflen into transform bufflen. Okay. Boss evaluate expression, and it has the same things except it doesn't have flags. We don't have flags here. And this can now become transform finalize. So I should have really thought about this a little bit more beforehand, but I wasn't thinking far enough ahead. There we go. Right, so pick up this function and put it in here. Oh. And we do the same for evaluate, because evaluate's a new one. And do the same for GS-trans, which replaces this one. There we go. And then we can rename the file into transform. Transformations on strings. Okay, there we go. Oop, no, I haven't changed that properly. That one still should say transform. There we go. Copy that and we'll put it into this one here where I missed it. There we are. Okay, now in here we need to replace the include. Include's now called transform. And down here we just need to change the functions we call. Oh, hang on, the finalization code also needs it. Transform final. Oh. Transform GS-trans. Okay. But since these routines are exactly, oh, bytes read. That's not how it's called anymore, is it? Because bytes, that's wrong. I'm surprised that worked. Because it should be like that now, shouldn't it? And that should be don't need bytes read there because it was already being handled as a uint32, isn't it? Yeah, it's a uint32 there. Okay, and we don't need braces around that now because there's no local variables. All much easier. But this also means that we, in the expanded section, we just change this to be evaluate. Same call, same setup, same setup, different call. Okay. Yeah. So having done that, I need to rename the file itself. Oh, hang on. This is transform. Rename the file. And its header as well. I think I've still missed some cases where these should have been used. Go back here. Ooh, we're not including our own header. That's annoying. The reason that I set these buffers quite small was so that I could actually test that the expansion worked, and I haven't done that yet. So we may need to have a tweak of that in a minute too. In fact, we can give that a whirl. A little while. Variables doesn't do anything with it. This does. Let's see what happens when we compile it. It doesn't work. Well, that's fine. Type not used. Transform GS-trans. Surely that is what I just did. Transform GS-trans. And there's a transform.h in there. Yeah. Did I typo this? No, I did not. A little bit confused now. A little bit worried that I've got something about the include paths that's going wrong. Because it should include the current directory first, and so it should be getting this transform.h. If not def transform.h, define transform.h. Discuss new. Right, it is now working. It's just, I think I hadn't saved the file and then I went and stepped through it. Module I want to be in. 170. Let's rebuild that and just see the actual errors. There we go. Right, okay, so we've got a couple of oddities in that. Why is that? That should be exactly the same because I copied the routine, didn't I? I thought I did. The only one that's missing is flags. Flags! Wrong number of parameters. I should have read the error message. If I'd read the error message, I'd have got it. ID. And yeah, so those functions don't exist because we haven't included them in the make file. O.transform instead of gstrans. There we go. One number of parameters to auto-evaluate expression. Interesting. This takes a buffer length. Takes a buffer length. So here we go. We want to do data and data len, I guess. File has changed on disk. Do you want to know what? I don't change on disk because I edited it. So I've changed this. Copy all of this into the header. Yeah. Semicolon on the end of it. And then I need to put that into the module, so I'm calling it properly as well. Data len. Try now. Yep, fine. Context not used. Okay. Evaluate expression. Okay, I'm doing something stupid here. Let me just copy the thing. Right, this is what it's trying to do. Expression. Oh, the data length doesn't. No, that's what I'm confused now. length of the buffer, buffer out pointer, or null if we got a string. And we wanted a number, yeah. Or number if it was red. So no, it wasn't. It isn't the data length that I was trying to do. That's not the problem. So we got expression, input buffer, buffer length, output buffer. What's that contain? Output buffer pointer, or null if we got a string. So right, I get it. I'm getting it now. Sorry. Oh, yes, this is interesting. The weird evaluate expression, because it can get back numbers as well. Null if we got a string. I don't know. I'm not quite sure about this. What's the implementation look like? It just passes the variables through from the evaluate expression. Viscous PRM. Zero if an integer. Right. It's because it's preserved. Okay, I get you. Zero if an integer. It looks like we've documented that wrong as well. Null if we got a number. Right. It's a fun interface, is that? It's a very fun interface. So, data points to the expression. This points to the buffer to write into. This is the buffer length. This is string. And then wrote is the output length, yes, or number, because, yeah, that's how we get it. So we're also going to have to be able to indicate that out to here, that we've actually got different values coming out. It's just weird. Let's just handle the So this is all the case of buffers not being big enough. We got our string or number. What we'll do is we'll also have a return in here of bool star is number. Is number points to number, points to where to store whether this is a number. Oh. all a horrible interface, isn't it? I'll rework this later, just because it's nuts. Right. Which bit was I saying? So I wanted to return is number. If, oh, hang on. I set that is string is in there, isn't it? Probably want that to be moved out of the loop to here. I'm going to make sure it gets initialized just for safety. If is number, then, oh no, hang on. If is, sorry, no, if is string was set, so that is number, should be a P, I should put a P on that, equals true, otherwise, yeah, strictly that is just the not case of that, but I'm going to be explicit about it just to be completely clear, because this is balmy. Is string goes into there, is number, P, we'll call that in there, because it's a pointer to the value we want it to be. And then all of this, all the way down to there, gets copied into the header. And then we cry into our drink, because right. If it is a number, and we want to put that on the end here, data equals ampersand data len, and oh no, that can't work, can it? No, that can't be a pointer to data len because I need to set data len. uint 32t number. Number equals data len. Data equals the address of num. Data len equals size of number. And the type also wants to change to be SVT number. And if it's been expanded, this has now become, otherwise it's a string. Type equals SVT string. Okay. Yeah, that's fair enough because that is a uint 8. Let's go T star. Yes, there's a bunch of casts here that I probably shouldn't need. Duplicate definitions of number. Where did I put number? Oh, numbers there. I'll call it data number then, because that's the number is the number of the SWI that was called, if I remember rightly. Bum, bum. Okay, type not used, context not used. a whole bunch of things here. That's probably because stud bool has not been included. Sorry. Implicit cast of non-equal. Which one? I really wish I'd got the change that gives me that the function argument details. I probably have got it, just I haven't merged it. It's that one. Shouldn't be a const star, it should be just jar star. There we go. Right, with that built, we can now try testing it. Looks good. Yeah. We haven't broken the existing system, which is kind of useful. Let's have a look at the test code. There we go. In fact, what I'm going to do is put some rems in here to make it different colours. Type 4 test. Type 0 test. And then we want an evaluate expression, which is, what type is that type? I've already forgotten. Evaluate expression is type 3. So, quotes in basic, so we need to double quotes to mean single quotes. What variable should we use? Not sys return code, not time. Come on, there must be a variable that's always set to something. CLI $prompt. That's always set to a star. I think that's a good one to use. The size of this string is 16 characters less 2, so that's going to be 14 characters. Sysname, we don't want to call it sysname, this is my eval. And what length should we get? We should get out a length of 1 because it should be the star, and the type returned was wrong. Type should be, it should come out as type 0 because we're actually a string by this time. So let's do that. Ooh, yeah, that worked. We got back a star, which is exactly what we expected. Cool. So this is strings. With strings, I'm going to do the same thing, but for a number now. Eight times 2. That'll tell us that we're not returning exactly the value that's brought back. So evaluate expression, type. If type equals 1, then else. the value comes back in then print number. Oops, number is in len. I think that's how you do it anyway. Let's see. And the length should be 16, I think. And the type should come back as being 1. Not sure that's right, but I could speed this up by not leaving the length was wrong. So the length has come out as being 5. That code is wrong, isn't it? Because I've not tested this. That should have gone with evaluate expression there. And this one should be evaluate expression as well. Read it in its natural form. Actually, I want to read this out in a literal format, not a natural format, so we get it out as a string. Oh, except we don't implement that yet, so I'm just going to have to get it out in its natural form. So there's two, you can read out the value as its natural form, which means you get back a number, as a value that's actually in that form. Right, okay, that didn't quite work. Yeah, that really didn't work. Test that setting the variable evaluate expression works with strings. No, we got some zeros out. The length was wrong and the type returned was 1. So it thought it was coming back with a number for that one. Probably means I've got the conditions around the wrong way. What? No, this is definitely correct that it's returning it for a number that way round. And in the transform code, oops, transform code, not the header. Yeah, that's the wrong way around. Whoops. This is why I should have done it the way. So if is string, then the number is false. Otherwise it's true. I should have just done that and then it would have been much easier. Yes, that would have made more sense. Run the test again. It should have given me not a 4, but I'm not sure now. Give me a second. Let's have a look at the documentation. Sorry. Right. The type of variable read is returned in R4. String is a string. Type number is a 4-byte signed integer. So it's returned the 4-byte signed integer. Then it's put it in. It should have just put it to the buffer. It's not doing what I've actually told it to do. That's why. So I think it's my test code that's wrong. So if the test code is wrong, number is the value at buffer. The length is always going to be 4 if it's a number, and the number, do that test at the end, if is not equal to 16, then Yeah, that's an odd terminology, isn't it? I've put those the wrong way. Was returned wrong. Type returned was wrong. I'm not checking the strings either, am I? That's interesting. I should be doing that. So if not equal to quotes, this should be hello A, then print value returned was wrong. And this one, it should be star, and this one should be the same string. Coming back. Okay, let's. Oh, hang on. Did I actually check the number? I did check the number. That's fine. Okay, go. Try all again. It works. That's cool. That's very cool, isn't it? I'm quite pleased with that. Which also means if we try setting a number value, I think it will come out correctly as well. Because I think number is already implicitly implemented by what we just did. Type 1 test. Right, so this is just setting a number. That's in the buffer. Buffer equals 42. Only passing a buffer of 4 bytes. Ooh, we don't actually need to have a different type, do we? We could actually just say there's a type that's got 4 bytes and there's a type that's got 8 bytes. We could have longer variables, numbered variables. That would be quite interesting, wouldn't it? Yeah, I think that might be something we could have a go at. Actually, let me put this into a little bit later in the buffer. Because if I put it into there, then if I read it back, it's going to come out wrongly. Length should be 4, type should be 1, and the value should be 42. Okay, so I think that should also test correctly. And it did indeed. That's nice. I like that. Okay, so good checkpoint time. What have we done in this change? We've added evaluate expression and numbers. Yeah. SystemVar val can now handle value 8 expression and setting numbers for the variables. So the only one we're not handling then is code variables. I think. Is that right? jump back over here and look at setVar. Oh, macro. Yeah, macros we are handling. We're just not able to read them back. So all the read types are not working correct. Actually, are they working correctly, the read types? Yeah, it's only the macros aren't doing it right. Yeah, that's good. Okay, so all right, so macros do the GS trans on the other side. They expand it elsewhere. So if we go and have a look at those, here we are. That's the writes. It's when we do the reads that we've got to. That's the wrong one. I want the read code. Read code. Here we go. No conversions from the variable types. So this is the type we want. So switch. Oh yeah, that's right, isn't it? So switch based on the type. Come on, there we are. And we have exactly the same cases we had previously, so let's copy them out. All of these. Case. So you'll notice that I've copied the natural, the natural format as well, so that we've actually got that form to be read. Right, so when it's the natural format, we do nothing. The strings and numbers. And code variables will come back as strings anyway. Numbers, right. We can only return it as a number if it was a number. So if, well, I think we can only return numbers. I'm pretty sure we can. var2, how do we get the type out of it? Type not equal to svt number. Return error bad type. If it's a macro, if it's expanded, this is a same meaning as natural. And variable type 3 always returns as a string. Right, so if var to type is svt number, I'm not sure if there's a constant for that value. I think it's either 9 or 10, I can't remember, but it's big enough anyway. Number does it with a number. Macro, need to expand, yep. Literal, need to convert to a string. So we would do sprintf send u, because all values are unsigned, into num buffer. Unit 32 is called T star. Oh, right, and I need to make some of these things a little bit more manageable. So unit 8 underscore T star is output. Var data, and the length is going to be unit 32 T var len, and sys var type T type, and each of these is going to be assigned these values so that we can manipulate them. Var data, oh sorry, var len, sorry. That's the name. That's actually going to be exactly the same. Var data is there. And var type is there. So now they're no longer in the var structure, so we can manipulate them. These want to come after we do the transformation, because we're going to be manipulating the data and it could be expanded or whatever. That's just a check for existence. Actually, a check for existence doesn't need to do any of these transforms. So we can just do that. Ooh, but does it need to know the data len there? Probably it does actually, doesn't it? So we do need to do a transform. So that should be var len. Should have called it var data len to match. There we go, do that. And I should update it there as well. And we shouldn't assign these before we've actually manipulated the values. This shouldn't have gone here. I was wrong about that. It should go here. Take that comment out, the other one's still there. Now we just change these so that they're manipulating operating on the values we've processed. Okay. So at this point, we can do var data equals ampersand num buffer. Just num buffer. Var data len equals that one, the output from sprintf, and var type is now svt string. Okay. So we still haven't done the expansion with GSTrans, but that shouldn't have broken anything. That should still be doing the same thing it did previously. That's probably because it just needs a uint 8 in there. Probably not been quite as consistent as I should have been with these things. No data len field. It's not called data len then. What's it called? show diff value.datalen and value.data. That does have what? 63. Oh, I did var data to data, then that's fine. Didn't read the error message. There we go. Right, so let's run the test on that again and just check that that's still doing it. Still working. That's good. But we've also added in this code that does turning a number into a string. So let's add a new test for that. So type 3 test here. Read as string, not natural. That's fine. So 4 is the natural type. So this should always return a string. And the string will then should be 2 characters. Hi Arctic. The type is going to be a string again, and the value of the string. The value of the string. Yeah, this is one of them. This is probably not very safe test code, but it will do. Is going to be 16. All right, let's see if that test works, shall we? Did not. String was a very big number. Ooh, that looks like a pointer. Huh. That looks like a pointer. That looks like I did the wrong thing. Have you ever tried to make an os just for fun? Yes, is the simple answer to that. This is my operating system. It's an implementation of RISC-OS in Python. You can try it out here. That's my operating system. Well, it's RISC-OS, but it's implemented in Python. I wrote it all from scratch. And almost everything you're using within it is written by me. Bits like basic and other bits of it aren't, but the rest of it all is. So yes, there you go. I think I've written the wrong value into here. So what have we got wrong here? I guess the question is, have we actually set this wrong, or is it just not doing the right thing? How much of RISC-OS is implemented in your version? Quite a lot. You go to the features, which I can't find. Features. You'll see a list of all the features that are currently present. So there's not like everything in there, because I haven't implemented the WIMP, for example. And there are certain other limitations. It doesn't implement hardware, for example, so you can never access anything hardware. There's only RISC-OS itself that's implemented. But yeah, that's what is currently implemented, is all documented on that page. I will paste that link to you as well. Can it run on a real? Can it run on real no-os computer? No. So this operating system is only intended to run elsewhere. Can you handle threads in your version? No. So it implements RISC-OS as is. The intent of RISC-OS Pyromaniac is purely so that you can test out and try doing things a different way. And since there is no program model, the application model is just not allowing for threads. RISC-OS doesn't support them. When that is done properly, we can implement it, or you could try it out in the code, but that's the way it is. It's relatively powerful system, and you'll see that when I'm running things here through pyrodev, in this command here, that's running it on the local version of RISC-OS Pyromaniac. When it needs to run the ARM code, it runs it in through the emulation, but all the rest of it is all in Python. If you want more information about it, talk.riscos.online. There are a number of presentations and discussions about RISC-OS Pyromaniac here that talk about it in different ways. So the original presentation shows a lot of the bare bones and basics of it, and these other ones build upon it. The presentation in 2022 was not a presentation; it was just a lot of documentation about what was done in different parts, because I never got around to actually doing a presentation itself. And other parts of this document how parts of that system work. So feel free to have a look. There's lots of words on the websites about that. Right. So what I was trying to do here was to find out what was wrong with this. So if I want to try and print out the variables, SystemVars list, I think that command probably doesn't work. So that would make 64-bit a little easier then. Yes, so the point of it was that the operating system itself was 32-bit, and I switched the emulation environment just to running 64-bit code instead, at which point lots of things broke because the expectations are completely different. You've got a different privilege model, you've got a whole bunch of obviously different instructions in the system as well, and different lengths of pointers. So there was a whole bunch of things that broke, but that was about a year or so back now that I switched it to 64-bit, and it's looking pretty good now. I mean, so what we can do here is if we want RISC-OS AMU, so we build for 64-bit instead of 32-bit. Is this going to work? Come on! Ooh, being a little slow there. Interesting. Interesting. Oh, it's on it anyway. There we go. Did I work for Acorn back in the day? Nope. I joined Pace very briefly and did some contracting through RISC-OS Limited. Pyrodev 64 GOS. So I'll just run start RISC-OS in 64-bit mode. Load arm32/.systemvars. Yep, don't load the 32-bit version, load the 64-bit version, and then help SystemVars. So this is all running 64-bit. There are no variables present, obviously, but you can do a disassembly of the module and see that it's actually 64-bit code. There we go. We can see this is all ARC64 rather than brain ARM code. So yeah, there's a lot of foundation that's gone into we're getting to this point where you can actually write modules and have things just cross compile. The fact that it is so easy just to switch the operating system in 64-bit mode like that, or to build the system using build 64, just one command slightly differently, means that a lot of the parts of the system just work, and there's no messing around with things. It's still not perfect, and none of it's going to be perfect, but it lets you try these things out and see what's going on before you actually have a real system. And the point is, this runs on Pyromaniac runs on Mac OS, Linux, Windows, and therefore you can try it out before you set the system up, before you actually have a physical hardware. And that was the point, was that the Pyromaniac is intended for developing and testing the system, not for real production use, because RISC-OS itself is quite atrocious in development terms. Anyway, what we were trying to do was debug what was going wrong with this, and I was saying that I think SystemVars dump was going to fail, which it almost certainly will, because if the type, yeah, there we go, we tried printing this out as a string. So what we want to do here is to go stop at that point there, and then decide what to do based on the data. So if type is 0, type is 0, thank you, then we can print out just this as a string. And if, I missed my bracket there, didn't I? Else if curved type is 1, I should probably use numbers here, shouldn't I? SVT string, SVT number. If it's a number, then we print out the number here. Oh dear, failing fingers here. Star uint 32t. Yeah, that should do the job. And then if it is anything else, we can just print out the words unknown, because then code variables don't do anything stupid. Oh, where's my one gone? I wanted to actually print out the value. Ooh. Oh dear, that's not going to work, is it? 3 parameters, but 4 given. 1, 2, 3. Oh, yes, that's because that should also be part of this one. Okay. And then I should be doing. How do you make a general compiler for all chips? I wouldn't know. I've never done that. However, have a look at GCC and how huge that is, or Clang. They are pretty huge projects. On the other hand, you can also have a look at TCC, which is the Tiny C compiler, and that is that the one that's by the same guy that did FFmpeg and a bunch of other things? I have a feeling it is, whose name I can't remember. Absolute genius, clearly. But they're, oh, that exits with an error when it fails, doesn't it? So I never get to see it. Maybe I'll rethink that. But have a look at those, because they're quite good. There's also something called Chibi CC. So Tiny CC is one of the ones you should have a look at. Yeah, there you go. No, not that one. Tiny C compiler. Fabrice Ballard. There we go. I knew he was a genius there. But yeah, thank you, Dave. You got there before me. There's also Chibi BC. Chibi CC. Chibi CC. Which is a small C compiler. That's also quite interesting because that's based on, it's an x86 x64 compiler, but the entire repository is written as here's how you start from the basics to actually build a whole compiler. Really quite interesting. And Arctic has also asked, LLVM IR good for general use? So LLVM is the backend for Clang, and IR is the intermediate representation. It's not. the intermediate representation is really only used for translating the high-level language into something that can be used by the low-level language, so it can be converted into C code. It's also useful for doing analysis, so you can work out how the structures are working. I have not used it like that. If you have a look at things like Capstone and Capstone the disassembler, you'll see that it uses LLVM's lower level parts as part of its disassembler. And I think there was another compiler that I came across. I'm sorry, it's on another machine. I can't remember the link to it. But there's a compiler whose entire purpose is you have a C compiler that produces just intermediate representation, and then you've got another tool that takes the intermediate representation and produces the low-level code. And then there's an ARC64 compiler for that, which then knows how to take the ARC64 backend for that, so it knows how to take that and turn it into ARC code. So if you're trying to write for many different processors, that makes a lot of sense. You can also have a look at CC65, which is a C compiler that targets 6502 and other small systems. I believe it also targets Z80 and a couple of others as well, possibly some of the 6800 series machines as well. But it's another good example of a compiler that you might want to have a look at if you're interested in that side of things. It's not an area that I know too much. I've spent a little bit of time recently looking at different compilers and the like, mostly so that I can work out what is a good way of taking RISC-OS forward, since there's a lot not happening. I'll include a command in here just to list the variables if we fail, so that I can see what's going on. Because I have a feeling that we're doing something just plainly silly here. That's probably all it is. So, yeah, these are coming out okay as 42. It's purely this one that when we try and read it as a string, it comes out wrongly. So Alan asked, what is the source code to Norcroft compiler like in comparison to the others you've mentioned? Norcroft is an older style compiler, so it's actually not, it's not dumb, but it doesn't apply a lot of the optimizations that the rest of the systems use. The optimizations it has are relatively limited. So at a high level, Norcroft is simple expression evaluator and manipulation of data structures and program structures, and then a peephole optimizer that will do some special things for ARM, because Norcroft was also intended to run for other different targeted chips. Whereas GCC and CLang do a lot of processing during the code generation phase. The code on it is pretty ugly, so it used to, in the version that I had, and I'm assuming the version that RISC-OS Open use as well, only handle everything as 32-bit, which meant that it didn't run on 64-bit processors. They used pointers that had munged values in them. They had unions of things that were pointers with integers and a whole bunch of other problems with that. So it was very difficult to work with to convert it 64-bit, to run on a 64-bit system. Norcroft is not particularly nice like that. It also has... No, I can't really say much else actually, because I just don't know compiler design very well. There's a lot of comments in there about, oh, we're going to do this, or this doesn't work because code is being lifted in a different way and things like that, which actually, from what I've seen in GCC and CLang, is probably quite similar. But it's very... Norcroft builds the code generator and the processors all into the same blocks, whereas CLang and I keep calling it CLang, it's Clang. Clang and GCC both use two different processes: the processor code and then the assembling being entirely separate, with an intermediate representation, in particular, as mentioned in the LLVM. So that there's some similarities there, but Norcroft is very simplistic by comparison to the modern optimizations that are done. And I imagine that's one of the reasons why ARM just abandoned using it. They basically gave up and said, right, okay, we're not going to use our own compiler. We're going to switch to using Clang and GCC and just support those. And then they contributed to that. Use everybody else's experience rather than just their own. And I think that makes a lot of sense. The other compilers, so Chibi, I can understand a lot of it, partly because it's intended to be understood. TinyCC is really interesting, and yeah, have a look at that one. It's quite fun, mostly because it is actually mostly written to be read, and it isn't as complex as the others. Yeah. And Arctic asks, would you make they would like to make a compiler, but many chips to compile to, and if you want to transpile to another language, I need to put people into downloading more stuff. Yeah, I think if you're going to write a compiler, that's a massive job, and the goal is get something working for just a system you know, and then start expanding out. You've got to remember that lots of chips, there are a huge number of chips and a huge number of variations of those chips with microarchitectures and the like. And many features of chips are optional. So FPA is optional in the early ARM systems, and it was largely implemented by emulation or by soft float. But then some systems had it. So you had traces on that. You had traces on whether there were certain co-processors present. On x86, you'll see the massive number of options available in the CPU. So there are always lots of things. It's a lot of variations on systems. I mean, if you were to look back, you can also remember, well, you might not remember, but these days you've really only got two major chip manufacturers, Intel and AMD, for x86. There were a lot more, but they've been subsumed into those two companies or just gone out of business. There used to be a lot of other environments that were, CPUs that were clones of x86 in various forms, and gave you a lot of extra performance for certain things because they focused on different things. And then you've got the other processors, the MIPS processors, the RISC-V processors, the special PIC processors, and so on. Trying to do everything for everyone is not going to work. And I think I've now talked quite a while. Yes, Cyrix was exactly the company I was thinking of, and I couldn't remember their name. Cyrix died, if I remember rightly, and this might be paraphrasing things, they did some exceptionally good integer processing and data processing in their processor. But their processing for certain operations was atrocious. They basically had if I remember rightly, Cyrix had a microcode architecture with a lot of optimizations in hardware for the really common bits of the integer side. But when it came to some of the things like division and multiplication, and I think it was particularly the division side, they just stopped. And went, okay, we'll just do that in microcode. So a lot of it worked really well for the integer-based world. And then games came along that wanted a lot more floating point things, and they wanted a lot more processing and the like, and Cyrix just didn't have it. They just did not have the floating point power. Yeah, Ben's reminding me it was floating points, yeah. And that was what killed them. They couldn't keep up with the others. They were a small place that had used standard fabs, and it just lost out. I mean, that's my recollection. Go and have a read up on it. There are also some really good articles online. There's There's a really good one that actually says Doom killed Cyrix, which isn't quite true, but I don't think. But it was a big nail in their coffin. They were already on the way out. I mean, Intel made screw ups as well. They had their whole Pentium division bug that happens like rarely. But the fact that it happened put a lot of mistrust into them, and AMD gained a lot back then. Yeah, if you were there back in the day, I think, yeah, FDiv, yeah, that's right, Ben. I couldn't remember it. You obviously remember it much better than I do. There was a lot of distrust and the like back then. AMD processors, again, as you know, are differently powerful. There was obviously a race. The amusing part of this is, of course, that Intel had a 64-bit processor, the Itanium. Itanium? I think it's called Itanium. But it was entirely different to x86 code. And AMD went, that's not going to work. You've got to convince everybody to change over to your new CPU. Plus, it sucks. And they went, we're going to write an extension to x86 and call it AMD 64, and it'll just extend the system. And because it's things that people know and they can just keep using their old processor, old infrastructure, it won't matter. They can switch between them if they need to, and that's what really made things work for them. And then Intel, they haven't killed Itanium. I think it's still running for some systems, but Intel just went, right, okay, AMD had the better choice. We'll embrace it, which was the right choice. Sorry, I'm whittering about CPUs now. Something that I only know a little bit about. Windows NT still has a version for Itanium. Oh my gosh. Yes. Yeah, because Windows NT NT was the first. Was it the first system, or was it OS2? OS2 that was the, I think, the first Itanium versions. Oh, I can't remember. No, my memory's gone now. Anyway, I'm getting overexcited, and it's already 20 minutes later than I wanted to be. I'm trying to work out what's gone wrong with it. I'll get this fixed, and then I'll stop, because it's been 3 hours, and as we know, that's a long time to be doing stuff. And I think it's because I did that. I think it's because I generated a pointer out of the variable. HP had a finger in it in some way. Did they build all the hardware for the Itanium systems? Oh, sorry, my memory is going on that side of it. But I now have a test that's passing, which I think means that we are good on this. So with that, I'm going to call this a day, I think. What have we just done? So we've just done implementation of, I didn't get round to doing GS trans. I was going to do that, and then I could have been, so macros. I could do macros there. Macros need implementing. The expansion here. Right, that's going to be a thing for next week. I thought I could get it done, but spent a lot of time chatting. Okay. So, added implementation, some words there, of the number extraction. Type 4 on read. So Arctic asks, why is there more than one chip type? Well, the main reason is that people see different benefits out of things. Yeah, why is there more than one car on the planet? So take for example x86. It is a power hog. It drains power like nobody's business. It generates a lot of performance. ARM was created as a response to that type of chip, following RISC principles, reduced instruction set. It's not really RISC anymore. In order to basically have lower power and to be more orthogonal. They have exceeded all expectations from when they first started, obviously, because they're all over the planet. But they've also made their way into data centers now because ARM chips are so power efficient that most of the time you don't need the memory, the power hogs that are the x86 chips. Same goes for PIC chips, the small microprocessors that you use inside like tiny devices. You might find them in the microcontrollers for switches and things like that, as in flip switches and things for doing timings and things like that. It's just easier to program those. You might find that you don't tend to find that you use PICs these days, but a lot of small electronics used to use PICs and the like for microcontrols. You'll still find, in some cases, people using 6502 Z80s for things because those chips were ones that they loved when they were younger, and also that they are really quite powerful for what they do. You don't need much more. They're still a bit of power drain because they're old style chips, but new ones have been produced for those that are more power efficient. And then you've got RISC-V, the massive amount of RISC-V growth that there has been because it's been using modern design techniques rather than building things in the past. Helen says there's a tale of the first boot of ARM that just ran off the signal voltage as they forgot to hook up the voltage line. Yep, that has been very well documented and is still a pretty cool thing. It's like, yes, we ran a CPU without connecting the power line. How awesome is that? I love it. And that just shows that the efficiency that they had so outstripped their expectations. Yeah. Again, it's just down to being what is the most useful for each environment. Look at it another way. So one of the things about memory is that memory can be accessed in many different ways. You won't remember it, but there were different physical types of memory that you used to have. Dear gosh, I remember bubble memory being a thing back when I was growing up. But there are a lot of different ways of accessing things. We're all used to the idea of bytes being 8 bits. That wasn't the case back in the day. Bytes were actually variable size, and the intrinsic size of data that you could store in memory or operate on has changed over time. The needs for particular floating points has changed over time. And some chips are well suited for doing floating point. Thanks, Dave. He says, tell me more about these olden days, Gramps. I think that is a sign that I should finish what I'm doing and call it a day. Ben Rogers has just said, it's the same thing on the planet. If someone wants a new standard for things, there'll just be another standard. They used to work on PDPs with 10-bit. Yes, I never worked with those, but I am aware of those systems having different limitations. If you ever come across, go and look at some of the old code for things like old code. It was 80s code, but things like zip and JPEG conversion and the like. They have a whole set of detections for Indianness and the little endian, big endian. And was it MIPS endian that was like randomly muddled? All of these things had different environment, different expectations. And it makes sense because for different targets, you need more specialized systems. Nobody settled on 8-bit as a byte for quite a while because, well, if you're dealing with ASCII, 6 bits is actually good enough. But if you're dealing with mathematics, actually, maybe you want 12, maybe you want 10, maybe a bit more. So Dave Plummer apparently has some videos on old code and his zip implementation, so that would be quite interesting to have a look at. There can be a huge amount of reasons why you might want to do things a different way, and many of them will just die out. Yeah. Oh, there you go. Got a link to those. Oh, Dave's Garage. Dave's Garage is awesome. He's an ex-Microsoft person who was there in the early days and explains a lot of the reasons why things were done a particular way and some of the politics. If you like reading instead of watching videos, you'll find there's a blog called The Old New Thing. Whose name I can't remember the guy's name, but it's a Microsoft blog by somebody who basically spends a lot of time working with systems. Right, I'm going to stop wittering now because you guys clearly are talking a lot more sense than I am, I think. I've added implementation of number extraction. We can now convert these to strings on return. Okay, that's done. Let's push that. Actually, I should probably go and update the version number. Vmanage increment the version number. Tag v0.02 and push the tag as well. Oh, actually, I should check whether it passed first. Should never push a tag before finding out whether it actually works. Raymond Chen, thank you. I had Chen in my head, but I couldn't think of it. Yes, Raymond Chen is a really good read, and he talks about a lot of modern things as well. Ooh, that'd be really cool. I will have to dig out of you if Dave's got a chat with him. Two very, very clever people from not just back in the day, but now. Push to origin. Oh, yeah, I'm too tired now, aren't I? There. And as I should do most times, build it. And build it for 64-bit as well. Oh, actually, can I just clean it first? That takes a while to build. Not sure why. I just want to clean everything out so we actually make sure we get the right build versions. Built properly. Right, and over here we've got the implementation building and it's done a release. So we go over to here. And look at the releases. Oh, did I not commit the bloody... Oh, right, delete that. Yes, delete it, sir. Oh. We've done enough to have a release. Push that, tag it again, force, and push, force. There. Yes, I know there's no releases because I screwed that one up. Nice chat, guys, for the end of this session. I know it's been I've been wittering a lot, but I do also enjoy chatting on things. Yes, Dave, I am a old person. It's very disappointing when I was at work and people were saying, "Oh, I'm old now," and they're like, "Oh, yes, I'm 40 next year," they said, and they're like, "Yeah, wait till you get to be nearly 50, and you still feel you're in your 20s." Well. Actually, I probably don't feel I'm in the 20s, probably late 20s, early 30s now. Ugh. It built. So we can now go over here, go to the release and say what we've got. Rob's apparently in his mid-50s. Yeah. It's nothing like what I expected it to be. You still feel young. Release 0.02 with tests wise in the module. creating variables, no updates. Creating, setting numbers, not macros, strings, and evaluated, and strings, evaluated, and literal values. Reading numbers and strings. No support yet for code variables, macro variables, OSY claiming. I think that's about it. I think we're actually quite close now to having something that would work, I think. Right, so I'm going to call that a release there. Dum, dum, dum. And I'm going to go and move RM32. You're still 28. Oh, young whippersnappers. Yes, I am old. No, as with everything, age isn't everything, and just because you're older doesn't mean you know stuff, because you miss stuff and you forget stuff, and stuff moves so quickly these days. Yeah, I'm old. Right, I've copied that into the 64-bit status repository, and I just need to have a look and see whether we need to update anything in the features, in features/SystemVars. Oh, you were 628 a few decades ago. Okay, fair enough. Oh, you see, you got me there. Oh, dear. Right, so we got string variables. Oh, I missed so number variables are done. And evaluated variables. They're also done. We haven't done the others, and we haven't got those interfaces yet. Okay, that looks all right. I'm actually not going to commit to it working in 64-bit. It loads, but that doesn't mean it works. So let's go commit that. Updated the SystemVars module with latest version. We now handle gestrans, evaluation, and number variables are balls. Right, and if we have a look at the status repository, which is somewhere here, don't know, can't find it. Yes, so Arctic was asking about the way to create an OS. Minix book is pretty good. These days you'll also see a lot of people writing stuff in Rust, and there's a lot of other operating systems out there that have just been thrown together by people just to do things. The website osdev.org, I think it is. osdev.org. No, osdev wiki. Yeah, that one. Has a lot of information about how you set things up, how to start writing them, and they also talk about different CPUs as well and how to do things. So you can get a good idea of the different types of system if you're interested. Many different languages will compile to machine code, and some will just compile to C. But have a look into that, and you might find some things there that will help you. Right, I have now merged this into the RISC-64 status repository. So have a look over here. We can now look at the status for all the components and find SystemVars. It says it's a stub. It's still really a stub at the moment, but it is nearly working. Yeah, and here we go. I've marked the extra bits that we now support. Okay, I'm going to call it a day there. Today, implemented just transing of things. We put in some Fortify handling to do memory checking. We've reworked parts of the handling of the system. I've just spotted a typo. I'm going to have to fix that. We've done evaluations, and the last bit that we just did was reading things out as strings for numbers. All of which has been a pretty successful day. We'll be back next week, but that'll be the last session for at least a week, possibly 2 weeks. Let's call it Sunday. Yes, that is a day. Yeah. It's been quite a long session, partly because I've been wittering, chatting to you guys. I like to listen to what you're talking about, and I can at least give my opinion on things. Even if it might be wrong, just remember you can correct me. Thank you very much, people. I will see you all next week. Well, if you wish to come along, please do. See you later. Bye.